Yeah.
Survival. You try to make it.
I think I'm like delusional. Like last night I was like, you know what? I don't need to worry. I'm gonna go to bed. I thought it all the time.
All those.
I do not.
Really not.
Oh, and apparently about
All right. So, Lucas, you wanted to look at number 11. This is it, right? Okay. So there's probably two different ways you could approach this. You could do a product rule kind of as it's currently written. You could FOIL this out and avoid having to do a product rule on it, or you could do something kind of in between where you could do a little bit of simplifying to maybe make the product rule a little bit easier, but that's kind of your three choices. Lucas, what did you try doing?
I tried doing the product rule just straight out.
Okay. So probably what we'd want to do is to think about this then as to think about those fractions as negative exponents. So our derivative then should be that first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. Lucas, are we okay with that initial step? And the derivative of y plus 5y to the third is just going to be 1 plus 15y squared, right? Everybody feel good there? Plus this thing plus, or times, and then the derivative of y to the negative 2 is negative 2y to the negative 3. And the derivative of negative 3y to the negative 4th is going to be positive 12y to the negative 5th. So far, so good? Okay. And at this point, the calculus is done. Anything that's left would just be like algebraic cleanups. So on a free response test setting, you could stop here. There's no need to FOIL this out, combine like terms. If it's a free response question, this is finished enough for me. It would be the same on the AP exam unless it specifically said, like, show this derivative is equal to this, where it needs you to fill in all the steps. Where it would probably be appropriate is on a multiple choice setting, right? If this is a multiple choice question, this would not be one of your choices. We'll do the cleanup here now and get to a better looking answer, but I want to point out, if a test coming up, like what you should do in a free response setting versus what you should do in a multiple choice setting, right? So FOIL time, let's see, what do we get here? We get y to the negative 2 plus 15, and then minus 3y to the negative 4, minus 45y to the negative 2. Is everybody okay there? Then continue foiling, so I'm going to have, well, I guess it's minus 2y to the negative 2 plus 12y to the negative 4 minus 10y, minus 10, excuse me, and then plus 60y to the negative 2. And we can combine some like terms here, so I have a y to the negative, I have a 1y to the negative 2, a 45y to the negative 2, that makes 46, and then 48, and then negative 108. Oh, no, that's positive. I got to start over again. So that's negative 44, negative 46, so plus 14, I think. And then I have a negative 3 and a positive 12, so that's a 9. And then I have a 15 and a minus 10, so that's a 5, I think. So there's that. Would they keep going? I don't know. I mean, depending on what the multiple choice looked like, maybe we'd have to do that. And then maybe even it would say, oh, let's make a common denominator here. And maybe we'd have like 5y to the 4th plus 14y squared plus 9 all over y to the 4th, maybe. I mean, at that point, it's like, you know, dealer's choice. They're all, I would say, equally simplified. It'd just be a matter if this is a multiple choice question, like, which version of these is the one in the multiple choice answer going to look like? But does that feel okay, Lucas? Adrian?
When it's like the minus 2 and the minus to the power, does it matter like what order you put them in?
Not really. I mean, like, standard form would be like 5 would be first, and then to the negative 2, and then to the negative 4, because usually we go, when we write up a function, we write it from biggest degree to smallest degree. So 5 is degree 0, which is bigger than negative 2.
That's not asking if it's like that.
Yeah, I mean, that would probably be the order it would be written on a multiple choice answer, but again, like, that's just like a convention. It's not, changes the rightness or wrongness of the problem. Does that make sense?
Yeah.
Okay. What else do you guys have? Peyton?
Are we gonna have to do any of like whatever the form was where it was like f of a plus h minus f? Like, do we have to do any of that in the test, or is it just doing this kind of derivative?
So, I'm not going to ask you to do any derivatives using the definition of a derivative.
Okay.
But where this might come in handy, if I ask you to say, like, we ask you to evaluate the limit, and we say the limit as h approaches 0 of Now, if I ask you to do this, that looks like a nightmare, right? What you want to recognize here is that this is just like that this looks just like the derivative where f of x is x squared minus 5x plus 4. So if you recognize that right away, you go straight to the answer without having to grind through any terrible algebra. So that's the way in which you should be able to use the definition of a derivative for this test, is you'll probably see that as a multiple choice type question.
Okay.
Where I give you a limit that's like, ugh, what the heck is this? It's going to take a half an hour for me to grind this out. The reason it's a multiple choice question is because if you look at it the right way and say, oh, that's just the derivative of this thing, then you jump right to the answer by using your derivative shortcuts. And that's probably the way that you would see the definition of a derivative. Or if it was like, you're given a graph and ask you to do like that same kind of limit where it's like, oh, I just need the slope of the tangent line. Or like, that's relatively easy. Or I use my definition of a derivative or whatever, and like, or I use my derivative shortcuts if it's like the product of like f of x times g of x, and they're both graphs or whatever, and you can just product rule it, then use your tangent line stuff. But I wouldn't expect you to like, there's no sense in like evaluating this via definition. Does that feel good? Did everybody else kind of catch on what I'm saying here? Adrian?
I'm just confused where you got the 2x minus 5.
So I just took the derivative of this.
Oh, okay.
Right? If that's the f of x that is in my formula, then this limit is just the derivative of that, which I can do in my head in like a second, right? Like, yes. Like how much busy work did I chop off by recognizing what I was looking at and go, oh, you're just asking me to take the derivative? Got it. Way better than trying to grind through the algebra on that limit. Which again, if you needed to, you could do, right? It's just time consuming. And lots of opportunities to like drop negative signs and stuff, but you know, if you had to, you could do it. Just, you know, if you could avoid it, save yourself the time. That's super helpful in a time test setting. What else? Do you guys have more stuff you want to talk about? Okay. Again, you could ask about multiple choice questions if you got a chance to look at those, or the free response questions if you had a chance to look at those, or the worksheet that I handed you, you know, or any of these previous homeworks. All that stuff is on the table. But I'm gonna, if it seems like you guys are done, I'm just gonna scoot ahead and we'll talk about section 3.3. This would not be part of the test, but we're gonna talk about it now, and it'll be part of test 3. Because I don't want to waste another class day doing nothing. We got to keep on moving. We have a lot of things to cover for the course, but.
Mr. Good, can you do one of the division ones?
Quotient rule problems?
Yeah.
So like 24 or something?
Yeah.
Okay. So. What's the formula for the quotient rule? If we call the numerator u and the denominator b. So the hesitation here is a problem, right? Like this is something you have to have stone cold memorized.
The bottom of it times the derivative of the top part for numerator. And then minus the numerator times the derivative of the,
All over.
the bottom.
Yeah. So again, good. Have to have that memorized stone cold. There's no like wiggle way around it. Like you have to have it 100%. Like make a flashcard, grind through it. Like make sure that the derivative shortcuts you know stone cold. Like and not just for the test, but for like the rest of the year. If you're an future engineering student, for the rest of your life. Like, you will not, these are things you do not want to be forgetting and have to relearn. Learn them now, learn them forever. That's the quotient rule. So it's the derivative of some function that can be written as u over v, some function divided by another function. Okay, let's We're just taking questions. All right. So this could get a little messy, right? The way this is currently written. So maybe it's worth just computing u, the derivative of u, and the derivative of v separately. And then we'll plug it into the formula afterwards rather than like we've written out the formula. So what's the derivative of 1 minus x e to the x? Nope. What's that?
Negative e to the x.
Nope. There's a product rule involved there. You see the x times e to the x? Have to use a product rule on that. Ooh, yeah. Mr. Kulik, will you do that to us on the test?
No.
Yes. Absolutely. Will I give you problems where you have both a quotient and a product rule inside of the same problem? 100%. I will tell that to you right now. You should expect to see that. Now, there may be situations where I give it to you and then you can like algebra your way out of it. But there may be situations like this where there's no escape. Except I wrote that wrong. That should just be an x there. All right. So we have negative x e to the x plus e to the x. Everybody okay with what we did there? Oops. It should be a minus, right? Is that what you're gonna say, David?
No, I was just wondering why does e of x, isn't it just, I might be just thinking the original.
No, that's okay. Go ahead.
So how do you take negative x, e of x, and make it into that?
So I have like, if I take the derivative of f of x, well, let's just use u of these, u times v. That's the formula, right, for product rule. And there, the order matters very little to us because it's addition. The quotient rule is the one we have to be careful about because with the subtraction, whether you do vu prime minus uv prime, or if you swap them, wrong answer now, right? So you have to be careful on the quotient rule where the order and the numerator really matters because subtraction is not commutative. Product rule, like whatever, however you want to write, just as long as you have one thing times the derivative of the other and then switch them plus and then switch them, you're good. So far so good? All right. Derivative of v is 1 plus e to the x, right? So now if we plug this stuff in,
Constant 0.
The derivative of constant is 0, but the derivative of x is 1. Yep. So what do we have? We have x plus e to the x times 1 plus e to the x minus 1 minus x e to the x times I didn't put that anywhere. Where was that supposed to go? Oh, I put it in the wrong spot. Yeah, that's right. And then I have minus u, which is that. Oh no, I did not put this in the right place. Okay, there we go. So Marcelino, there we're at that step. And again, at this point, the calculus is done. So you could be finished here. If it's a free response question, now if this is a multiple choice question, surely that's not going to be the answer. What are you going to have to do? Yeah, you have to FOIL out that the numerator there and
then divide.
and see if you can reduce, right? I don't think any reducing is going to happen, but let's give it a shot. All right, so we have negative x squared e to the x minus x e to the x minus x e to the 2x minus e to the 2x minus 1 plus x e to the 2x minus e to the x 1 then minus plus x e to the x. And then I see some stuff that's going to combine. What do we got here? Got those guys will cancel out. And then I have, is that it? No, those guys cancel out. So we'd be left with just then like e to the negative, or negative e to the 2x minus x squared e to the x minus e to the x minus 1 all over this mumbo jumbo. I think. Marcelino, are you happy there?
Yeah, it's not like you cancel this stuff out, but that's only if we have multiple choice, right?
Yeah, so if this was a free response question, you'd be fine stopping here, and that I would count still. Again, the typical rule should be if the calculus is done, you've done all your derivatives and stuff, you've applied all your derivative rules, and it's free response, you can stop. If it's multiple choice, you have to go until you've gotten a simplified answer. Simplify until you've gotten an answer, or you can tell which answer in the multiple choice is correct. I guess you don't actually have to get there if you can see where it's going to end up at.
Do you have to do any like writing or like proving like, oh, because of this rule, it's this or no?
Well, I would say that you should still remember how to check for like continuity, because continuity and differentiability are related, right? How are they related?
If you're continuous, then you're, or like you're, yeah.
What's this? What is the relationship? There's two parts in it. One of you started and finished, and I didn't. What's the full statement?
You can be continuous but not differentiable, but you have to be continuous to be differentiable, or something like that.
Differentiability implies continuity, but the reverse is not true. That continuity does not imply differentiability. So certainly in a question, I might give you something that's piecewise and ask you to check the continuity and check the differentiability of it, since the two are obviously related. So that's, again, remembering how to check for continuity, specifically with a piecewise function, should be something you remember how to do. And we did that practice on the points back assignment a bunch of times, which, by the way, if you have one of those and want to give that back to me, that would be great. Don't have to get it out right now, but a lot of you some of you have turned them in, some of you haven't yet, just reminding you since I haven't been here in a little bit. And the other place is that, like, again, because continuity and differentiability are related, I think the IVT can still pop up and rear its head. the difference here is that, if you're given a function that's differentiable, and you want to show that, like, it can have, can it take this value? How are you going to get the continuity from that? You just say that differentiability implies continuity. Now you have your continuous function. You just need to find, like, the y that's above and below whatever you're looking for. And that's basically all you need. So yeah, those two ideas, I would say, still should be fresh at your head. Those won't go away, as they're kind of core for many things going forward. So you may see aspects where you need to use those again. So that's a good question. Certainly, if you want to ask about, like, hey, what kind of old stuff might still be here? That's fair. Again, this is the exam at the end is cumulative. This is kind of a cumulative class. Like, math is kind of cumulative also. There'll be things that we do that just don't ever go away. That you just see coming up over and over and over again, even on future tests. And part of that by design, where I try to do that, since that's what you're going to encounter in the AP exam, and it's nice to see how, like, two concepts can be related together inside of the same question. But that's the idea. Does that feel good?
Yeah.
So those would be the two places where most likely things from the previous test might still come up here again. Adrian.
So for the denominator, I know you said we would have to, like, sometimes if it's like a multiple choice, you might have to, like, factor or FOIL out the numerator, but, like, most of the time when you find to leave the denominator just like how you left it.
Yeah, I don't think there's any reason on a problem like this ever to FOIL out a denominator, because if you want to, like, what we ideally want to be able to do is we hope that maybe there's some factoring that can happen and I can reduce. But if I have to factor, the denominator's already in a factored form, right? If I FOIL that out, I just have to factor back to get it there to check to see if I can reduce anyway. So almost never am I going to touch a denominator unless I have, like, something squared plus something squared, and it's like, okay, well, maybe I have to FOIL these two things out and then combine them together to see what's going on. Like if I had a complex fraction that I was simplifying, there's a situation where, like, maybe I can see wanting to, FOIL out a denominator to maybe get something better. But
like quotient rule though.
But for a quotient, well, almost never would I do anything with that. Almost never.
And then, other than the stuff that you talked about with Peyton,
Yeah.
is it like the main two rules of that you have to have memorized is the quotient and the product?
Along with all your, like, derivative shortcuts, right? Like the power property and the derivative of an exponential is e to the x is just e to the x, the derivative constant is 0, and you can, like, pull constants out front and distribute the addition, or distribute the derivative through addition subtraction, like those kind of basic rules. Yeah, I think that's more or less covers it. Is that?
Yeah. Thank you.
Sure. Okay. Everybody feel reasonably okay? Let's talk then about section 3.3. Who loves trigonometry? We're going to be talking about derivatives of the trigonometric functions here. So the first idea, we look at the graph of sine x and look at the place where we have a horizontal tangent. Those map up exactly with the same locations where cosine has an x-intercept. And I think we encountered this in a homework question before, where we sketched the graph of the derivative of sine and made a guess that it looked like it was the graph of cosine. I think that's a homework problem we did in a previous section. Well, that is the case. The derivative of sine is cosine, and we're asked to prove this. If we wanted to prove this, what are we going to end up having to do? If I want to prove a derivative rule, what do I almost always end up having to pull out? Limit definition of the derivative. Oh, are you joking, Mr. Kulak? Unfortunately not. So, again, if f of x is sine x, the derivative is the limit as h approaches 0 of sine x plus h minus sine x all over h. And again, if I do a direct substitution here, I end up with 0 over 0. How am I going to try to clear that indeterminate hurdle here? What can I do? Like, I'm multiplying by a conjugate, it's not going to get me anywhere because there's no radical. There's nothing to FOIL out.
Can you do with reciprocal?
What reciprocal would you want to do?
Would you take like 1 over sine and then divide them out?
Well, they're different signs, right? One of them is sine of x plus h, and the other sine x. So I'll give you a hint. That's the thing we need to work on. Is there a rule from trigonometry for the sum of two angles? You're like, maybe, Mr. Kulik, but I don't remember what it is. You know what? I don't remember the rule either, so I have to look it up every time. But there's certainly angle sum rules. So I'm gonna back. What do I run somewhere? So sine of x plus h is sine x times cosine sine x plus cosine, or times cosine h plus cosine x sine h. Now what? Right? So we have two sine x's here, correct? So I'm going to group those together. And so do a little rearranging there. So if you take a look, this piece is that piece, right? You guys see it? And those two green pieces, I just factored the sine x out front. Oops, that negative's in the wrong place, right? It should be that. Is everybody okay? What's the limit of that as h goes to 0? You did it all. All of you did this problem already. David, it's 1. How did you know that? Where did you do it?
Isn't it the sine of 0? Yeah, sine of 0 is 1.
The sine of 0 is 0.
Oh, it's cosine.
The limit as h goes to 0 of sine h over h is 1. That's the correct answer. You guys have all done this problem.
Why is it 1?
Where did you do it at?
Yes, sir.
This was the first problem on your points back assignment. You guys all proved that the limit as as x goes to 0, sine x over x is equal to 1 using the squeeze theorem. Remember I gave you the picture and asked you to set up the inequality for the squeeze theorem? That was something we did. Oh, Kate's like, yeah, okay. Now that you say it, I did it. Okay, so that's 1 there. Everybody's okay with that? So we still have this piece, though. What do you suppose cosine h minus 1 over h is going to be as h goes to 0? What do you think that limit should be? The answer to this question should be just cosine x, right? So we know that we expect it to be 0. Right. That is what we'd expect. How are we going to get there?
Is it the same thing because it's sine?
Well, it's going to be a similar type argument. Yeah, you can algebra your way through it now that we have, since we know that this is 1. Well, you have to kind of make that fall out of it, which is not so simple. But yeah, this is going to be 0 also. Do you guys want to see this? If it's not something I'm going to ask you to repeat? It's okay to say no here. Because it's going to be like, 5 more minutes of trig identities. Which Marcelino's like, please God, don't tell me that. So this is going to be 0 here. And so you're left with just cosine x, which is what you want. So again, this we did. You guys all did that on the points back assignment. Or you will if you haven't finished the points back assignment. You're like, ooh, I forgot about that. This is what we just stated. Again, to do this, you have to multiply algebraically. You multiply the top and bottom by cosine theta plus 1. And then you can use like some Pythagorean identities to get that a sine squared, negative sine squared to fall out of that. And then you write it as like, sine theta over theta, which is just 1 times the other stuff. And now you've kind of cleared your indeterminate hurdle and things will, you can make a direct substitution. I think things will make or work themselves out. And so there's our end. All right, let's look at some examples of kind of doing something with this. We want to differentiate x squared times sine x. How do we do that? What are we going to need to use? Very good, a product rule. Everybody sees there's two functions here. There's the x squared times the sine x. And algebraically, there's no way to combine those variables, right? Because I can't push the squared inside of the sine. You're stuck. These are separate. So our derivative is going to be x squared times the derivative of sine plus sine x, the derivative of x squared. What's the derivative of sine x? Cosine x. Very good. Make sure you're writing x's. If you just say cosine to me, I know what you mean. But like on your paper, make sure you don't drop those x's on the tricks. And the derivative of x squared is 2x. So maybe we just write that as x squared cosine x plus 2x sine x. Be probably how they'd write it on multiple choice question. Does it feel good?
Is that like always like sine is the or cosine is the derivative of sine? Is it like the other way around?
Well, the derivative of cosine turns out to be negative sine. So again, I'm not going to prove that, unfortunately. No thanks. You know how we do it? Basically the exact same method as we used it to do the prove the derivative of sine as cosine. We even cheated our way through that a little bit where we got to one limit. We're like, I'm just going to tell you that part is 0 so that we can be done with this and it's not so bad.
You will never ask us to prove what these are.
No, using the limit definition. No. Now, to prove the derivative of tangent is secant squared, we can do this now without the limit definition. And I think that that's kind of a fair problem. Let's look at that. So, what I'm going to do, rather than using the limit definition, I'm going to rely on the fact that I know the derivative of sine is cosine, and that the derivative of cosine is negative sine. So I want to start by rewriting tangent in terms of sine and cosine. What is tangent in terms of sine and cosine? Sine over cosine. Hopefully you guys still remember that from last year. Those basic trig identities, like tangent is sine over cosine, or secant is 1 over cosine, or sine squared plus cosine squared is 1. Those tier of trig identities, I would say, are still fair game. The expectation is you still have those basic identities memorized. Now, the double angle and angle sum and differences, no, I would not expect you to have that memorized, nor does the AP expect you to have those memorized. But the basic ones, yes. So if I want to do the derivative of sine x over cosine x, what do I need to use? The quotient rule. Exactly right. So I'm going to have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Very happy? What's the derivative of sine? Cosine. And then cosine times cosine is? Okay. The derivative of cosine is? Negative sine. And then negative sine times negative sine is? Positive sine squared. And cosine squared plus sine squared is? 1. And 1 over cosine squared is just secant squared.
Can we write it either way? Do you have to write a secant squared?
No. The reason I wrote it as secant squared is because that has proven this identity, right? But 1 over cosine squared is fine. Means the same thing. Is everybody okay? So this level of proof, I think, is certainly doable for you, right? Where we're just going to use the derivative rules for sine and cosine and then a product or quotient rule. And it should be relatively easy to handle, right? Nothing tricky has to happen here, other than remembering some of our basic trig identities. Does everybody feel good? We could continue doing this for cosecant, secant, and cotangent, but I'm not going to. I'm just going to state the derivative rules. So to summarize here, we have these 6 new derivative rules. Are these things that you will need to memorize? Yes, 100%. Will you need to have them memorized for test 2? No. For test 3? Yes. And forward? Yes. I know. The best I can tell you is just memorize this well enough so that your children will know it. Right? I don't want to belabor the point, but at some level, the memorization has to be that good that it's instantaneous recall and you have it stone cold. It really helps. Take a problem from odd. I can't do this because I don't remember the rule. Or I have to figure that out to just, I know exactly what to do because I have all the rules I know I have stone cold and I know how to use them. All right. Let's look at this next example. It says differentiate secant x over 1 plus tangent x. For what values of x does the graph of f have a horizontal tangent? So it's a 2-part question, right? First, I need to find the derivative. And then I need to set that derivative equal to 0. Solve for x, and then plug those x's back into f to find the actual points.
So
The y coordinate.
and then make it a line.
Well, it doesn't say, I guess it just asks for what values of x. It doesn't ask for what points. Sorry. It just asks for the values of x. Okay. So if you look at this, what does it look like we're going to have to use here? Looks like a quotient rule, right? Now, this particular quotient rule, I think is going to get kind of gross because I have 2 trig functions in here, both of which kind of get more complicated as I differentiate, right? I don't love the idea of having to solve something that's going to have secant squareds and tangent times secants in it. To set that equal to 0 and solve, Yukaruski. So what I'm going to try to do is do a little bit of algebra beforehand, because looking at this, I the looks of where this is going to head. Not that it's not doable or that I wouldn't be able to do the cleanup afterward, but usually it's easier to clean up first. So that's what I'm going to do first. So I'm going to look at this and I'm going to go, okay, secant, that's 1 over cosine. Tangent, that's sine over cosine. Right? What do you notice about both of the small fractions? The denominator is cosine, right? So what I'm going to do is I'm going to multiply the top and bottom of this fraction by cosine x over 1. I'm going to like clear fractions here, like we would for a complex fraction problem. I'm going to differentiate that, which seems way simpler to me. I love the 1 in the numerator.
I
Right?
love the 1 numerator. I also do. How's Minkum, you guys? Is it really good? Well, see, the 1 numerator. What's the denominator?
Cosine x plus sine x.
Really, really good. I won't interrupt you anymore. Have a wonderful day, everybody.
Bye, Miss Sager. She did startle me. Did you jump a little bit? I did too. I did too. Yeah. All right. So let's do our derivative now. So we're going to have the denominator times the derivative of the numerator. Ooh, yeah. Who likes that? You should. And then times the numerator, or minus the numerator times the derivative of the denominator. All over denominator squared.
So does that whole first term become 0?
Yes, it does. Gone. 0. Why? Look at it closely. What did we take the derivative of in that first term? A constant. And the derivative constant is?
0.
And 0 times anything is?
0.
And it's gone. Yeah. Very nice. All right. And the derivative of cosine is? Negative sine x. And the derivative of sine x is? Cosine x. There's our derivative, right? Everybody happy there? No reducing I can do. But that's not too bad. If I take that and set it equal to 0, how do I solve that equation? Set equal to 0.
Is there any value for sine x minus cosine x?
Nope. When is a fraction equal to 0?
Oh, numerator.
If the numerator is equal to 0, right? And the denominator is not, right? Because if it's 0 over 0, that's not 0. That's good. Okay, how do I solve sine x minus cosine x equal to 0? Trig skills are so rusty, guys. Always have been. All right. So I would subtract sine from both sides. And then divide both sides by negative cosine x. And what's sine x over cosine x? Tangent. Is tangent equal to 1? Pi over 4. And
3 pi over
5 pi over 4. Third quadrant and first quadrant, where both the signs of sine and cosine are the same. And then we should say, like, right, plus 2 pi k for k, any integer. Right, because you go around the unit circle another time, pi over 4, you do a full circle around, and then there's another answer, and another answer, another answer, another answer. And is cosine plus sine going to be equal to 0 at any of those values?
That's 0.
Won't equal to 0, right? Because they're both either both positive or both negative. So if you add them together, they can't be 0. So there's our answer.
Can you do this any trick like that? I don't know.
For test 2?
Yeah.
No! You don't know how to do any? You didn't know how to do any trigonometric derivatives till today? Test 3, yeah, but that's a problem for like, that's a month later, you know? It's like a November problem. So far, so good? An object at the end of a vertical spring is stretched 4 centimeters beyond its rest position and released at time t equals 0. Its position at time t is s equals 4 cosine t. Find the velocity and acceleration at time t and use them to analyze the motion of the object. So position is 4 cosine t. What's the relationship between position and velocity? Very good. So the derivative of 4 cosine t is going to be negative 4 sine t, right? Everybody's okay there? And what's the relationship between velocity and acceleration? It's the derivative of it, right? What's the derivative of negative 4 sine t? Negative 4 cosine t, right? Everybody okay there? So there we found velocity and acceleration at time t. And now if we want to analyze the motion of our object, so at t equals 0, at t equals 0, the position is 4 cosine 0, and cosine 0 is 1, so that's 4. Velocity is going to be negative 4 sine 0. That's 0. Sine of 0 is 0. And the acceleration is negative 4 cosine 0, which is negative 4. So initially, the position of the object is 4 units past stretch point or whatever. Velocity is 0. Unsurprisingly, it's at rest. The acceleration is -4. What's the -4 on the acceleration coming from? Probably the tension on the spring, right? Like as soon as the instant you let that go, the spring's going to try to return back to its unstretched position, right? Everybody's okay with that? Just like if you have an object you're holding up in the air, like above the ground, the velocity is 0, but the acceleration acting on it, gravity's still acting, even if you're holding it up, right? If we stretch that spring and we're holding on to it, there's still an acceleration trying to pull that spring back to its unstretched position. Everybody okay with that? And we'd expect that acceleration to be going in the opposite direction of the stretch. Right? If we stretch the string down, it should be moving in the opposite direction. Right? If position is 4, positive 4 here, the acceleration should be moving against that in the opposite direction. You guys buy that? And we could do a similar kind of analysis at like t equals, and I'm going to do like, I'm going to pick a crazy time and pick like pi over 4. Why would I pick this? I don't know, just because I can easily plug it in to sine and cosine, like that's a unit circle angle, so I know what it is. What is that even? That's like 0.78 seconds or something. So if I do that, I just kind of do the same thing. And it's going to be 4 and root 2 over 2. So we've gotten, the spring is now moving back up towards like the 0 position, right? 2 root 2 is going to be like 2.8 something, right? Less than it was before. Velocity moving in that positive direction. Oh, sorry. It's in the negative direction, as we'd expect, right? It's moving back up towards the origin. And the acceleration now is actually decreased, right? Before it was -4, and now it's negative like 2.8. Why is the acceleration decreasing here? Because the spring is now not stretched as far, right? The spring is contracted a little bit, so the force pulling the spring back up is decreased because there's not as much stretch on the spring. Is everybody okay with that idea? So if I look at this, I'd say, okay, the position of the object is at root 2, or 2 root 2, and it is moving, like we're moving back up, since we defined that as like the negative direction. And we're accelerating in that direction because the sign of my acceleration matches the sign of my velocity. So we're accelerating up into that position. Everybody okay with that? If the signs mismatch between velocity and acceleration, then the acceleration is actually slowing the thing down, right? So at some point you're going to move like past the origin and going to start moving up, and then in which case the acceleration should change direction, but the velocity will still be moving against. You know what I'm saying? In which case, when those two things disagree, you have the thing being slowed. Anyways. So just like a way of looking at and analyzing this. If Find the 27th derivative of cosine. Now, do you think we're going to do this? No. What should we do? Do it a couple of times and look for a pattern, right? Everybody good with this? So the first derivative is negative sine x. The second derivative is negative cosine x. The third derivative is sine x. The fourth derivative is cosine x. Stop. What did you notice? Where do we start at? Where's the fourth derivative at? Same thing. What have we just done? We've made a loop, right? So 1, 2, 3, 4 derivatives gets us back here, right? Second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, 21, 22, 23, 24, 25, 26, 27. 27th derivative should be just y equals x. So if you find a cycle, like a loop, you just kind of make a clock and just count around the clock. This idea is like modular arithmetic is what we call this in a technical mathematical jargon. It's a really important, actually, type of mathematics, especially when it comes down to computer science. A lot of the cryptography, the way that we secure messages sent over like a public network, are built around that type of mathematics, modular arithmetics. I don't want to do these two. I think that's enough for today. So there's an assignment attached to this section. When should you start this assignment? After the test. Don't worry about this until you've done the test, right? Even if you're rusty on it, need to go back and ask some questions in class later. That's okay. No big deal. Worry about the test for right now. How do you guys feel after today? Okay? Again, you got dumped a bunch of memorization on you today, but that's a November memorization problem, not a today memorization problem. I think I have a Quizlet I made for these derivative rules that I'll post for you eventually here. I don't think you probably read it before test 1 because there's not much there, but for test 3 I definitely have one because there's quite an iceberg still to uncover of derivative shortcuts here for test 3. We have all the trigs, and we have the inverse trigs. We have exponential rules and logarithmic rules, and it's a lot still to come. But that's a later problem. Any questions for me on stuffs? What happens next class? And the format and everything we've talked about already, right? You guys feel okay about stuff? I'll be around today and tomorrow if you guys come across something you want to talk about. You could try sending an email over the long weekend. I don't know if I'll have a chance to get to it. I'm pretty buried under catch up from being out. But I'll do my best. You guys be patient with me. You know, there's a lot going on right now, especially with conferences and stuff. So that to deal with. So you're welcome to give it a shot. I'll get back to you as best I can. Okay. We feel all right? You glad not to have the test without having a chance to talk to me first? I feel like we talked about some important stuff today in terms of like, ooh, that can happen. Ooh, I still need to remember that. Ooh, it was probably a good thing that we can do with anything to get to. Like, I can brush up on a couple of things still. So, okay. I'm done. How are you guys? How's the stress level currently? It's okay? It's alright?